So let's get into this. So first things first, if you have not signed up, I remind you have to do this. No ifs, ands, or buts. So I'm going to openly tell you, this is a grade. You have to sign up for this. This is the way we communicate in this class. I literally already have 2 videos uploaded to YouTube and the links ready to be sent out to you. They're scheduled.
It was underneath my desk. You have 2 over there.
My daughter. My daughter.
That's what I blame it on too.
Well, she came up here Friday.
You just throw your stuff everywhere and then blame it on her.
I colored my wall too.
Poor thing.
It's all Hannah's fault. So make sure and get signed up for that. All the videos, everything will be sent out like that. That's a line of communication from you to me. Literally download the app, you got it. You can even sync your number to it if you want to, and it'll send you messages through it. Now, you cannot communicate from your text messages through Remind to me. You have to physically go into the app. But you can have it set to where whenever you get a Remind message, it sends you a text to say, hey, you got a Remind message. Which some of you probably ain't going to do that because on days of labs, I send out a reminder, hey, remember, you have lab today. And everybody gets mad. So it's like, my gosh, did you have to send it out at 6 a.m.? Yeah. Some people are getting on the bus by then. Some people are already on the bus by then. All right. So, working through these, yeah.
You said like you have to send out that notification for lab. What do we have to do differently on days of lab?
It's your attire, how you dress. So you can't wear clothes like open-toed shoes. Some labs we do, you can't wear contacts. Just different little odds and ends.
What we do where we can't wear contacts?
You're dealing with chemicals that if it got in your eye, you wouldn't want the contact in there. Because 2 things can happen: the contact can fuse to your eye, and you have to have it surgically removed. Or 2, the chemical will get behind the contact lens, and it doesn't matter how much water you spray in your eye, the contact lens is protecting the chemical so it can eat through your eyeball.
That's awful.
That's why you don't wear contacts.
I don't even wear contacts, period. So.
And that's also why you wear goggles. Everybody's excited for lab now, right? Don't worry, you don't start off with the good stuff, okay? It takes time to get there. So, we got step 1, write the number down. And something other. We got to find what's the same and the difference. So, grams is the same. We're looking at the difference between mega and nano. Exponential value for mega is 6 minus, what's the exponential value for nano? Negative 9. So we stay, change. 6 plus positive 9 is 15. Do I need step 4? No, because there's no exponent on the units. Do I need step 5?
No.
No, because I don't know. Start with the exponential value, so it's just 87.3 times 10 to the 15. Second one's a little bit more beefier. 47.2 times 10 is something another. We got to find step 2, find what's the same. So dB is the same. dB stands for decibels. It's a unit of sound. And anybody that wants to look at me and say, you cannot make a volume out of decibels, Mr. Hall, I'm fully aware of that. But there comes a point, we just run out of units that we got to cube something. Why?
This is a stupid question, but if it's already written down at the start of the problem, like 47.2 times 10, you don't have to then times that by 10. It's already, the times 10 is already written for you.
Correct.
Okay.
But you want to make sure that you get 47.2 times 10. So, here we go. We're going to go from pico to tera. So, pico to tera. Pico exponential value is?
Negative 12.
Minus tera is?
12.
Gives me?
Negative 24.
Nice. Negative 24. Look at step 4. Multiply by the exponent on the unit. Is there an exponent on the unit?
Yeah.
So when I multiply by?
3.
So everybody see this. So what we're going to multiply by? So negative 24 times 3 is?
Negative 72.
Negative 72? I can't do it in my head. So. Negative 72, then we are going to add any exponential value that we start with. Did we start with 1?
Yes.
Yeah, start with a 5, so now we got to add 5. Negative 72 plus 5 is?
Negative 67.
Negative 67.
Because there's a lot of words out there.
So negative 67. How are you feeling?
I'm feeling
I feel
good.
awful. I did so bad.
That's because you're sleepy. You're doing fine with this. How the rest of y'all? How y'all feel about this? Feel good with it? Okay. I do have a practice sheet, which obviously I can't give you right now because the printer decided to look at me and said, you know what, forget you. You came in 20 minutes early. You're already planned ahead. You're ready to go. I'm going to ruin your morning. But that's okay because Jesus is good and God is good. We're just going to roll on with life. You know? We can't let things get us down. This is chemistry. So here's what we're going to do.
We could let it get us down really quickly.
Making a little bit of a change on the fly. We're going to start in with some more notes. I will give you a practice sheet on this later on. By the way, this Friday, dun, 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 your first quiz. So I have good news and bad news. Which one you want first?
The bad news first.
You have a quiz on Friday.
Okay. I can live with that.
Good news. It'll be one of the easiest quizzes you get from me. It is the safety quiz.
Oh, okay.
Yeah.
I thought it was like an actual quiz.
No, it's going to be a safety quiz. The reason it's going to be a safety quiz is one, gives you a little bit of confidence boost, get you a high grade. Second thing is it's a requirement. I have to do that before you can literally do a lab. So I want to go ahead and get that out of the way. We should have class changes and everything done by then. I will literally give you a safety contract that you also have to have turned in. You'll get a grade for it as well. You're going to see, you're going to feel like Mr. Hall is like Oprah Winfrey starting off like, you get some points and you get some points and you get some points and then you all get a quiz. It's actual chemistry content quiz. And you're like, what is this? It's a quiz. Okay, so with where we're getting ready to go, we have to talk about the basis and the foundation of what chemistry deals with. So in order to do that, we focus on the three. We're going to focus in on the three subatomic particles. Now, I'm going to address an elephant in the room. Mr. Hall teaches biology. Mr. Short teaches biology. Mr. Short is an incredible teacher. Mr. Short is a biology teacher, and Mr. Hall is a chemistry teacher. Whenever I teach biology, I teach it more focused in on biochemistry and the chemistry. Why? Because you just can't break me of it. It's my stuff, man. And that's what I like. So we're going to go through, and for some of you that had me, we started out on chapter 6, which was chemistry. This is going to feel like a review for you at first, which is good. It should. For those of you that did not have me, this may not feel as much as a review. That's partly part of a review because Mr. Short discussed things with you, while other aspects he did not go as deep with because it was not needed for the biology class. It's needed in chemistry. So I go deep. Why did I go deep in chemistry? Biology? Because it's my stinking class and I like it, so I did it. So, bear with us. It's going to be fun.
I think someone said chemistry 3 times in that mirror. I mean, Mr. Hall just started teaching with that after that.
I like you light a candle and just say chemistry because then you get a beer.
Oh!
Alright, so the 3 subatomic particles. Hopefully you know what the 3 subatomic particles are. I know for a fact everybody sitting in this room should know what 3 subatomic particles are because you had me or Mr. Short last year and we both covered them and we both know them and you know them. First one.
I hate to tell you, but my biology...
Oh yeah, you're a senior, so that's different.
Yeah, I'm sorry.
We have the proton, then we have the neutron, then we have the electron.
I knew that.
So we're going to focus in on each one of these. You have to have a very deep understanding of them in order for you to be successful in this class. So the first one we're going to go in a lot of depth with is the proton. So when you look at the proton, it's a positively charged subatomic particle found at the center of the atom. Now this is also where we'll start getting you familiar with another piece of information that is out there. Don't worry, I'll pull mine out. The periodic table. I'm sending dust bunnies flying. Stay. Thank you. So, when we talk about things, you're going to see the periodic table is going to be a piece of information that's going to be staying with you, that'll hold with you, that you're going to have to be familiar with. Pieces of different information. Over here on the view board is actually the periodic table I will constantly be giving you until you're in AP Chem and you sign up for AP Chem, then you get a totally different one because I'm going to give you the one they use in the AP Chem exam. So whenever you look on the periodic table, over there it's the same. They have the element name and then they have the atomic number. But the first thing we have on this one is the atomic number. When you look at the atomic number, it's very special. Every one of them is a whole number. There's a reason for this. Whenever you break it down and you look on the periodic table, the thing called the atomic number is the number of protons. So the atomic number is equal to the number of protons that we have. And this is fixed for each element. So let's say that I have an element with 6 protons. Well, I have carbon. This carbon has 6. Let's say that I have an element that has 1 proton. Well, I got hydrogen. If I have an element that's got 3, I got lithium. They're fixed. All these are fixed. Which leads me to the question that is what got chemistry started in the first place. What happens if I change the number of protons in an atom? I want you to take 1 minute and 30 seconds and think to yourself, 1 minute and 30 seconds. Hey Siri, start a timer for 1 minute and 30 seconds.
1 minute and 30 seconds, starting now.
Nevaeh, give everybody a second to actually try.
I feel it's pointless to even write this down. I already have it written down.
There are actually several of you in the room that actually have this like pretty down pat. Alright, take 1 minute, 30 seconds discussing your groups. What happens if I change the number of protons in an atom? Go at it.
Even changes the element or creates. I'm gonna look more towards changes the element.
I'm telling you, that is what happens, it changes.
Did he say AP
I'm
chemistry? Who takes his classes like, I want more of this.
That's why he doesn't have an AP chemistry class. Because nobody.
I imagine people that take AP chemistry are just like, almost like tweakers at this point. Because anatomy is better. Because they're fun. It's them going off all day. I love both of them,
Hey,
which is why
come
I'm
talk to me whenever you start on the skeleton.
I'll be halfway through the year at the point, probably.
The skeleton's easy.
It's the muscle which I think
You got extra give you a
Oh, that's a different part of the t-shirt. It's the one that I stole out of the room that I knew was not being used. All right, what you got? Throw it at me.
Changes the element or creates an imbalance within it.
It changes the element,
Changes the element. How do you know it changes the element?
because you're changing the mass by changing the protons, and so it changes to a different element. The atomic number is what it is, and you're changing that.
You getting ahead of me. I see you.
Smarty pants. By the way, you proved my point. You knew the answer. You know how long it's been since you had this conversation with me? 1 year.
Oh, yeah.
Yeah. Yeah. Why would you want AP Chem? People like him was going to be a pharmacist would die for an AP Chem class with me.
I think he's already dying for just a regular chemistry class.
He's in one. You know, he got his wish. It's a perfect example. If I have carbon, it has 6 protons. If I take a proton away, how many do I have?
5.
But do I have carbon anymore?
No.
You got boron. If I got carbon and I add a proton to it, I get
The end.
nitrogen.
Yes.
Sorry. This one I got the names on. I got to remind myself you guys ain't used to the names yet. So you get nitrogen. So what happens whenever I change the number of protons in an atom? I'll go ahead and tell you 2 things are going to change. First, we change the element. In this class, you have to be able to explain things, though. It's not good enough just to look at me and say it does this. You should be able to explain why it does this. How do you know it changes the element? Each element has a fixed number of protons. If we change the number of protons, we have to change the element. Yes?
Yes, sir.
Yes, everybody understand? Now, there is a second thing that happens here, but I'm not going to tell you yet because I have to give you some other piece of information. So put the number 2 and leave you like maybe 2 lines. Okay? You're going to want like 2 lines there. I ain't writing nothing, it's just a 2 lines, and then you will write what I'm putting up next. I'm going over here for you people that are short over there. You can't see over the periodic table, you shorties. Get taller, my goodness. Ridiculous. Brings me to a question. Where does the mass of an atom come from? Somebody besides Nevaeh. You want to take a shot? Go for it.
The neutron.
Half credit.
The neutron and proton combined, or something like that. It's two things combined.
So the mass of an atom is equal to the number of protons and the number of neutrons. So if I change the number of protons, what else am I changing?
The atomic weight.
The mass.
Well, the mass of the atom. So the second thing that's gonna get changed is the mass of an atom. That looks like an N. So this brings into what really is a neutron. What's the purpose of a neutron? When we look at neutrons, these are subatomic particles with no charge found in the center of the atom. So it has no charge, it's found in the center of the atom. Well, what the world? Why do you want these? Brings into question is, what's this got to do with anything? Here's the thing. The other number that's down here, these red ones, are what we call the average atomic mass. Mr. Hall, go ahead and tell you. Mr. Hall going to foreshadow again. Class of curriculum. I used another English word. Okay?
It's just the same English word you use every day.
No, only on Monday through Fridays.
Uh,
Yeah, you're good, man.
It definitely talks about that.
But the average atomic mass, man, you look at the average atomic mass, the average atomic mass is going to be something you calculate. It's coming. I tell you. Yeah, we're going to do math tomorrow, man. You'll be happy. I'm excited. So the neutrons are there. They add to the mass of the atom, which leads me to discuss to you the average atomic mass.
You got that nice, right? I don't know why you would.
Is the average mass of an atom taking into account
You got nothing.
Real American class.
Thank you. Don't worry, it was just a motorcycle accident. It happens all the time.
the average mass of an atom taking into account the percent abundance
Yeah.
of each isotope. Now, we'll discuss percent abundance more likely tomorrow whenever we go through calculating the average atomic mass. But here's the thing, a term that you're probably not familiar with, isotope. For those of you that had me should be familiar with this. Those of you that had Mr. Short, you should be pretty familiar with this too. Pretty sure Mr. Short covered it. Hold on a second. You people decided to come short to class today, so let me get that out of your line of sight. Can't be tall like everybody else, thank goodness. Let's talk about isotopes. We have the isotopes. An isotope is atoms of the same element. With different masses. Of different mass. Okay? And I'm not talking about that thing you do if you're Catholic on Sundays. I'm talking about, mass, Your mass. I mean, I'll use Caden for example. Okay? Caden, I'm gonna use you for example. Is that okay?
Yeah, man, you're.
Thanks, man. You know, Mr. Quarterback back there. So over there taking a nap about halftime of the game on Friday. I'm like, it's one of those you look at and you say, you one incomplete, dude. Could have been better. Come on. Have a good time coaching that one. You know, pretty impressive. Impressive performance. Especially that one run you had, man. I thought they had you at 3 yards. Got to 3 yards, and I was like, ooh, look at that move. Ooh, ah.
This is coming back to chemistry.
I was happy I had the mic off. I'm working today. Okay, you take me and Caden for example. You know, you compare me and Caden. It's okay. You can say what you're thinking. I'm not nearly as good as an athlete as him. You didn't see me in my prime, man. I wasn't a quarterback, but I was pretty good. I was an offensive lineman. But anyway, I know that isn't shocking anybody in the room, but
I was just gonna say that he had glasses on.
this guy over here, okay? Make a comparison between me and Caden. What do you look at us and you go, there's a big difference.
You're bigger than he is.
Jesus.
My gosh!
Okay, so you're really gonna tell me that that's not what you were wanting me to point out? Literally all biology, you got that, and they wouldn't say it. It's the truth.
Ridiculous.
City coming around a little bit.
Somebody get that knife out my back? Oh my gosh. She's meaner than my doctor. My doctor just looks at me and is like, it's your weight. You know, very nice. I'm just kidding. That is what I want you to notice. What's the difference between me and Caden? I'm a lot bigger than Caden. Okay? You know, you watch SpongeBob. I gotta pick on you, I'm sorry.
So
Watch SpongeBob. Caden's, you know, he's mini. Mr. Hall is one bow. Mr. Hall been investing in one bow for a long time. You know, so long that doctor looked at Mr. Hall and said, Mr. Hall, you need to stop investing in one bow and you need to start investing in diet.
So a lot of protons and neutrons is what I'm hearing. Lots of them.
Yeah. Mr. Hall got a bunch of these neutrons. Caden does not have as many neutrons. But that's okay. We are both people. It's like isotopes. Same element, different masses. So when we look at isotopes, it brings the question up. What is changing
The neutron, because the protons changes the element.
in the terms
Either that or that.
I think you heard you.
of isotopes?
Either that or the electron.
So, when you look at this, what's going to change? I couldn't have said it any better myself, you know. David doesn't know it, but David's proven my point. My change in my teaching style was a very successful thing that I did. Because look at you, a year later, and you're still answering the questions right. So when you look at this, what is changing? The number of neutrons. Oh, that's abbreviation for neutron. I don't think any of you got that.
He didn't.
My bad. The number of neutrons, I did up there. The number of neutron is changing. How do we know that? Can't change number of protons. If we did, that changes elephant. We can't change the element. Why can you not change element? What's the definition of an isotope?
Same element, different same element.
It's the same element.
Smith, Alora Lester,
But
and Raylan
different
Jones
mass.
from Counseling Office.
So this is what we're looking at. Every time we're looking at this, man. Okay, you need to go see Miss Keisha Stewart Crocs.
Probably.
Probably a scholarship. He is on his way now. Hey, have a great, wonderful rest of your day, everybody. I'm getting a printer to work. Mr. Hall will have you an entry slip tomorrow. come prepared and ready. We'll finish up with the neutrons and the isotopes, and we start on the electron. All right, Stu. Hopefully you guys feel pretty good about these. You feel good, yeah? Feel solid, you know? Get the hamster back on the wheel today. So we look at this. 87.3 megagrams equals how many nanograms? Step 1, write the number down. 87.3 times 10 to something another. We're going to find step 2. Find what is the same. Find what is different. We're looking at the difference in the prefixes. Are you taking notes? This is going to be on the quiz. So, grams, little g's, are the same. Means grams is the base unit. So we're looking at the difference between mega and the difference in nano. I caught myself. So, what's the exponential value in mega? 6. Minus the exponential value in nano. -9. So, subtracting a negative is the same as adding a positive, or as you guys say, stay, change. Sounds like that. So change the signs. 6 plus positive 9 is?
15.
15, very good. So 10 to the 15. Any questions on that one? She always steals the show. Where are you going? She's got a marker. You better watch out. All right. 47.2 times 10 to the 5th picodecibels cubed equals how many teradecibels cubed? Now here's the thing. Do you have any idea what dB is when it comes to decibels? No, it's a unit of sound. Go ahead and get this out there. Yes, I am fully aware that you cannot cube decibels and get a volume, okay? It's a unit of sound, I totally get it, but you know what? I run out of units, everybody. I can only, make so many volumes of things. Step 1. Write the number down.
Angel Lester to the office, please.
2 times 10 to something another. Step 2, find the same, find the difference. Find the base units, dB.
Coy Canada to the counseling office, please. Coy Canada.
dB. Are they, is that something you're probably familiar with? No, but it doesn't matter. You got this. Don't let Mr. Hall trick you up because I use units you never see before. Who cares if you know what this is? Throw it out there, okay? dB is the base unit, so we're looking at the difference in P, pico. Oh, pico de gallo. Some chips. Oh, man. So good. Capital T for tera. Now, the 3, find the difference in exponential values. What's the exponential value for pico? -12. Minus, let's say exponential value for tera. -12 minus 12 is? -24. Good now? All right, -24. Step 4. Do I need to do step 4? Yeah, what do I do? Times by 3. Why not 5? Because you multiply by the exponent that's on the units. Okay? -24 times 3 is? That's what I heard. Yes, -72. Now, what do we do from here?
Add 5.
Add 5, because that's the exponential value we start with. So plus 5. -72 plus 5 is? -67. How you feel? Feel good?
Yeah.
Questions here?
She might need a little help.
Hey, you got this?
I see.
That's a marker. What color is that? That's right, it's green.
Good luck, everyone.
I got a little back here. All right, no questions? All right, so here we go. I do have a practice sheet for you guys. I don't have it printed and ready right now, mainly because my printer decided it didn't like me today and bit the bullet. So, all is good. I will have a practice sheet for you guys eventually. We'll get a practice sheet on. So, I got good news, I got bad news. Which one you want first? It's a green marker. Bad news? Friday you have your first quiz.
She's had a heart attack.
The good news is so much can be said right there. All right, anyway, you ready for good news? It's one of the easiest quizzes you're gonna get from me. Safety quiz.
No, what would I do in college?
It's practically common sense, you know, like you have an open flame. Do you A, set the flammable material next to it, B, throw the flammable material on your lab partner, C, put the flammable material completely away where it's safe and sound, or D, spread the flammable material all over your lab station that has an open flame on it.
Yeah.
That's the marker cat.
Green.
Hey, I'm trying to do chemistry, girl. Focus here. All right? We are going to shift gears, okay? So we're going to go away from the metric conversions for a little bit. They do not leave the class. You're hijacking my class. Where are you going? Cracks me up. We are going to turn gears and we're going to focus in on the 3 subatomic particles. So the 3 subatomic particles are the basis and foundation for science, for chemistry. So you have to understand them in deep detail, okay? I said this to the first period class, I will say it to you as well. Some of you in here, two, maybe. That's it. I think only 2 of you had me for biology. 3. 3. Okay. She's okay. So 3 of you had me for biology. I went into a lot of depth and detail in bio because the truth of it is I'm a chemistry guy. So whenever I'm teaching biology, I'm teaching it from a biochem standpoint. Any chance I get to do some chem, I'm really going to go deep with some chem. Mr. Short is a biology teacher. He went into some detail with this and described some things. I'm going to take it just a tad deeper with you, but you'll be fine. So, we're going to talk 3 subatomic particles. Hopefully you know what the 3 subatomic particles are. Everybody in this room should know. The 3 subatomic particles are 3 very well-known things. First, we have the proton. Then we have the neutron. Then we have the electron. Would it help you if I like clear off a spot on my desk? I'm okay. You good?
Yeah.
She's all over the place. So, Going into it, okay, man, here we go. We got the proton. So the proton is abbreviated with a P plus, all right? And the proton is a positively charged subatomic particle found in the center of the atom. Now, I know you guys covered this. I know every one of you heard this. All good to this point. But we're going to make some changes and a little bit of a shift here. We're going to go a little bit deeper with things. All right? When we look at these, there are pieces of information we use with this. And for those of you in the room that are seniors that I'm not thinking about, if you had somebody else different for biology, you'll be fine. It's not a massive change. This is my backup periodic table. I got this one, I got that one. I print like 1,300. You guys will literally be able to wallpaper your room by the time you're done of this chem class, the periodic tables. So the proton, when we look at the proton, there's a certain piece of information we can actually find on the periodic table. That periodic table over there on the viewboard is the one I actually print off and give to you. And it has it labeled for you. So the first thing up there is the element name, and then the next thing is the atomic number. The first thing on this periodic table is the atomic number. So if you look at it, why you gotta keep walking up that way? Like literally. Only kid in a wheelchair gotta roll away. So when you look at it, all these blue numbers have meaning. So if you look at boron, boron has a 5. What that is, does anybody know?
It's the amount of protons are.
Look at you, very proud, very proud. The atomic number is equal to the number of protons. So that's what these are. It is S. We started off good. Started good with S. Then we go into O and P. And I'm pretty sure she called it O yellow. This class may be a little too advanced for you, sweetheart. You might want to drop. So anyway, the atomic number is equal to the number of protons. So if we look at it, take carbon for example. Carbon has how many protons?
6,
Very good. Then let's go to nitrogen. Nitrogen has?
7.
So here's the thing. What happens if we change the number of protons in something? So this might be the smidge bit where I take it a little deeper than what you went in your biology class. What happens? Man, I like that black marker a lot more. What happens to the atom if I change the number of protons? Take you a minute to yourself and think about it. Just 1 minute and just think. Hey Siri, start timer for 1 minute.
1 minute, starting now.
Alright, now, take you a minute, talk to the people around you in your group behind what happens if we change the number of protons in an atom. How about it? Hey Siri, start timer for 1 minute.
1 minute, starting now.
I think that's what it is.
What y'all think?
I don't remember any of this.
We did this last year, but I don't remember.
Positive or negative reaction? I don't know.
Carbon got 6.
It changes the element.
Bingo. Change the protons, we change the element. What do you think? Look in your eyes.
I think it changes the mass, so like it messes up the numbers.
All right, here we go. Okay, I'm gonna go ahead and say this. There's 2 things that happened, but I can't give you the second thing yet. I gotta tell you something else before I can give you the second thing. So the first thing, what happens if I change the number of protons in the atom? It changes the what?
Element.
Very good. Very good. Thank you. You're proving my point. Made me feel good. It's been a year since I taught you this. Look at you. So the first thing that happens if we change the number of protons in the atom, the very first thing that's going to happen is we change the element. This is how chemistry got its start. If you don't know the history behind chemistry, don't worry, I do. I'll inform you. Chemistry got started out with everybody trying to become rich, so everybody was trying to make everything into gold. Chemistry did not have a very good start because we had some people that it was like, seriously, dude? Like there was a guy that looked and peed one day and he was like, huh, my pee is yellow. Gold is yellow. There's gold in my pee. He boiled it. You do not get gold from pee, everybody, okay? Don't go home and try this. Now, we're gonna put a number 2 here. And you want to leave a line because we're going to fill in another piece of information, but we have to add something to it. I have to add some things to you for you to figure this out. Slide this down a little bit. We're going to stop maybe blocking y'all's point of view. Got some short people over there on that side. You pointing fingers for me. My gosh, dude, that was mean.
It was just videos.
So the question I have is where does the mass of an atom come from? Okay, go ahead, if you know it, just throw it out. Where's the mass of the atom come from? Okay. And what?
And proton.
The proton, the neutron? Okay. What about the electron? I know.
They're just 6 small. They would be considered as a
Man, I feel good about myself. That's a year ago I taught that. Thanks, Joe. So mass in an atom. Mass in an atom comes from number of protons plus the number of neutrons. Which brings me to another point that I have, to the second point that happens. Casey, right? Yes, Casey. So, when we look at it, what's the second thing that gets changed if we change the number of protons in an atom?
The mass.
The mass. So the second thing is going to change. We change not only the element, but we also change the mass. She didn't prop that door, did she? She'll be knocking in a minute. So here's the thing that comes into part. Probably tomorrow, we're going to go a little bit more in depth with it. But up there on that periodic table, they're there also. So I showed you the blue numbers, but do you see the red numbers? These have a name as well. Do you know what they are called? No. All my proudness is now gone. It's okay, I'm still a little proud. I mean, especially because you knew that word, electronegativity. Come on. You know what it's called?
Oh, the, perhaps, what colors? Polarity.
You're just grabbing the straws at this point. It's called the average atomic mass. Now, I'm going to define what the average atomic mass is for you, but besides me defining it for you, I'm also going to look at you and tell you we're going to do some calculations with it. Hello. How you doing? I'm up. Did you have NyQuil? No. How many melatonin gummies? None. None? None. Okay. Wakey. You don't want to miss this. Fall asleep, man. Who falls asleep during chemistry? This is like, I'm not even eating caffeine. Average atomic mass is the average mass of an element taking the percent abundance and isotopes into account. Now, we'll break down percent abundance more tomorrow, but percent abundance is like, hey y'all, how much this is of this? It's kind of like, you know, it's pretty much just a percentage thing. So, when you look at this, the other word we have is the isotope. Now, you probably have no idea what isotopes are, maybe not. Okay, some of you may. If you do, that is good. You are ahead of the curve. Very good. But if you don't worry. Mr. Hall will tell you what the isotope is. Mr. Hall, so nice. Isotopes. Isotopes are atoms, the same element, but have different masses. It's just like math. Okay. I have perfect example for you. Yes? Okay. Perfect example. So to get you to understand what an isotope is, what I want to do is draw a relationship with it and people. All right? So, Hunter, right? Braxton? The world?
Hunter's in the wheelchair.
Oh, my bad. I'm all mixed up, man. Trying to learn you all. All right. You can help me in a second? Come on. You don't want to go on.
We had 2 set hours, but
Listen, don't get a walk there around that way. Don't y'all blame me, okay? You blaming me, saying he had to choose the now, I had the wheelchair guy at the front of it. That ain't my fault. He could have walked the wrong way.
Yeah, Braxton.
All right, come over here.
Are you?
Okay, I promise you, I'll put the other on. Okay, took a shower, everything, man. All right. You look at us two. Okay. What's up, man? You doing good? Cool. Cool. Okay. Now there's an obvious difference between us two. Okay? When you look at us, what do you see as the difference?
You're what's taller?
Oh my gosh, really? This guy back here. Well, it's like, man, I cannot say what I'm thinking because if I say it, I'm in so much trouble. It's like I gotta find something else. It's not the answer that I'm thinking of. You got glasses! Next thing you're gonna be like, you're a little bit taller than him. And then it's gonna be like, he's like a lot more athletic than you are. It's like, okay, man, like, how do you know my athletic ability by looking at me?
How does that?
Ridiculous.
Your facial hair?
Get this, man. This, my gosh.
He did
Listen,
got a
you got a mustache, okay?
Yeah, sure.
Got the little mustache.
I got a joke.
Really, come on, what's the difference? I give you permission, people, you can say it, okay? Dear God. Everybody's scared to say it. You scared to say it? What's the difference between me and you?
Joke, just say it.
Somebody read it off the board. Thank you. Okay? Now, is he a person?
No.
Yeah. Wise guy. He a person. Am I a person? We both people? Yeah, we're both people, right? What's the difference? Everybody's scared to say it.
You have facial hair.
Okay. I'm fat, people. I'm fat, okay? I'm fully aware of it. Don't worry, okay? Like it wasn't even like a huge... I went and see my doctor before we started school, and she was like, you know, it's your weight. And I'm like, oh yeah. Yeah, you know, I mean, it wasn't a big shocker to me.
Maybe Braxton's just premature. He just hasn't hit his full potential yet.
No, you can go sit.
Braxton, walk around.
You just lost 8,000 weight.
Hey, look at that. Come on, right? You gotta stop being so nice. Somebody comes by and says, you just looked up. Really, dude? Really? Go around.
That's what I'll start doing.
You are too nice. All right, so Mr. Hall, there's Brad. I'm big, okay? You know, if it makes you feel any better, Mr. Hall's fat. We're not talking the PHAT. It's a different meaning. Mr. Hall is the FAT. All right, not fat. It's okay. I'm comfortable with it. I'm comfortable with who I am. I'm working on it, okay? Mainly because last thing I want to do is go back to Dr. Childers in 6 months and her look at me and go, What have you been eating? Like cotton candy? Like, dude, seriously, I said lose some weight. Look at you. So I'm working on it. I got a good doctor, but man, she don't hold punches. She mean. So anyway, brings me to a question. Isotopes in mind. What is changing when it comes to isotopes? I want you to take we'll do a minute, okay? I'll give you a minute to think to yourself, what is changing here, okay? Hey Siri, start a timer for 1 minute.
1 minute, starting now.
This is always the funny part at the beginning of kids coming in my room because they're just staring at me like, my gosh, this is so awkward. It's like quiet. Bless you. Thank God, man, y'all made that like the most awkward 1 minute in the history of my life ever. Not really, I'm just kidding. Anyway, so I'll give you a minute now, talk in your groups. What's changing? Hey, here's the key. You're getting a minute not because you're just saying what is changing, you're explaining how you know it's that it's changing.
Oh my God.
Yeah! Make noises too.
I'm sorry. That's my language.
Hey, serious, start
You ain't been up
time.
for
1
this.
minute.
You ain't even been awake for
1
this.
minute, starting now.
I don't even know what I was going to say. I was like, where is this even going? I know where I was going, but I was like,
Okay, can we put that in like an understandable?
It is the new code.
So,
yeah.
Take my name. She's gonna make me.
Tell her that I'm not going and Christy said that I'm
saying
good.
it, but he's not saying it.
Let's take her baby things tonight and I'll play the outside.
What makes it
Yeah, she's probably gonna make that.
Okay.
Tell her you ain't going.
Why do you know it's going on?
Allison is not going. I don't care what Caitlin says.
And then
Bingo.
she's gonna go to practice tomorrow.
Somebody's bad.
We're not that.
I would say, I've been going every single one. I missed one.
All right, here we go. Here we go, man. I'll tell you what. Good question here. Good question here. So, what is changing when it comes to isotopes? I was over here talking with this group, going around in a circle with somebody. You throwing off on her for it. I don't even think she's in your group. See that? She's like, what's wrong with you? So what's changing when it comes to the isotopes? Okay, so the neutron's changing. How do you notice the neutron? What makes up the mass of an atom? So protons and neutrons. So if I change the protons, I'm changing the mass, so that's what's changing in the isotope. So why can it not be protons changing in the isotopes? It would change the element. The key to the isotope is it is the same element. We cannot change the element, therefore we cannot change the number of protons, neutrons, because if we change the number of protons, we change the element. You cannot change the number of protons. If we do this, you're definitely going to change the number of elements, which brings in the big question, what in the world is the purpose of a neutron anyway? Just to make things heavier? That's stupid. What's a neutron do? You got your notes from last year or something, man? Or is it just in there? I did that good of a job? Yes. So when you look at this, what happens is neutrons bring stability. To the atom. Okay? Here's the key. Bring stability, but sometimes makes things unstable. That seems like it's defeating the purpose, but it kind of does. That's where we're going to drive home tomorrow. The neutron brings stability, but it also can bring instability. So, I'm pretty sure the bell's getting ready to ring. Pass me your entry slips. You want to, you can, like, go ahead. You got somebody that you trust to take you. Look at that.